Okay, we are talking lesson number 56. Which is talking about angles and circles. So the first part is we're going to be talking about, there's no other place that you could possibly watch this graph. So if I have a circle, and then remember if I had, this is my center point here. Here's my center. Not really in the center. Hold on, let me move that a bit. Okay, and then we'll say that I have this angle that stems from the center. Right? So I know that if I have an angle that's, the vertex is the center, the measure of this arc here, the measure of the arc equals the measure of the central angle. So if this was 70 degrees, this angle here is 70 degrees. Okay, so if this is 70 degrees, that means that this piece here is going to be 360 minus 70, which is going to equal 290 degrees. Okay. So the endpoints of one arc, right, the endpoints of this arc are also the endpoints of this green arc. Okay, if the two arcs are not equal, we call the longer one the major arc. So this green arc here is the major arc, and the pink one here is the minor arc. When we name the minor arc, we name the endpoints and use the arc sign. When you name a major arc, we name the endpoints and one other point on the major between the endpoints. So let me show you what I mean here. So if I were to use the minor arc, all right, if I want to name the minor arc here, let me just putting some points, okay? I'm just moving these around here. For crying out loud, no. Okay, whatever. So now I'm going to go ahead and fill these in. This is A, B, and X. So the minor arc, you just use the endpoints, right? So I have minor points A and B. To list the major arc, I would use a, this is an X, A, X, B. Okay, so minor arc has the two endpoints. The major arc is going to have another third point in there. That's what they're saying. We also know that if two circles have the same radii, we say that the circles are equal or congruent circles. So if I were to have another circle here and my radii are the same, then those two circles are congruent. Okay, so what your takeaways here? The bigger arc is your major, right? And to list to list a major arc, you need 3 points. And to list the minor arc, we use the two endpoints. And if you're talking arc, you need to have this little arc symbol over it. Okay, next page. Next page. Okay, so if a line intersects a circle in two places, that is a secant line. So let me go ahead and draw some pictures, or let me draw some circles here for you. So now I have two circles. That's more of an ellipse. Okay, so I have these two circles here. And if I were to have a line go through 2 points, right? So it goes through this line here goes to the point there and there, right? So I can say that this line intersects the circle in two places. This is called a secant line. So let me write that out for you. This is a secant line. The part of the secant that is inside the circle is the chord. Okay, so let me highlight that. So this right here, is called the chord. If a line intersects or touches a circle at only one point, it's called the tangent. Okay, so let me illustrate that for you. I'm gonna do my very best here. What I'm gonna do is I'm just gonna draw a line, and I'm gonna move it a smidge over. Okay, and then I'm gonna highlight this. So it only touches the circle at this one point right here. Okay, come on, Janelle. So this is a tangent line. This is a very important concept for you to understand, because once you get into calculus or even pre-calc, what you're doing, see if I were to find the average rate of change for these two, this secant line here, right? I have a line here, so from this point to this point, I'm just finding slope. But what's going to happen when you get to calculus is these points are going to become closer and closer and closer to a point of tangency. So you really have to understand the difference between secant and tangent, right? And these are also, secant and tangent are also inverse trig functions that you're going to be learning down the road. So this is, I understand it's a little abstract right now, but just understand the secant touches at 2 points and the tangent touches at 1, okay? And this pink dot right here, that's your point of tangency. And a tangent is always perpendicular to the radius of the circle. So that's super important to write down, that the a tangent is always perpendicular and I'm gonna, let's hope I can fit it here, perpendicular. No, I can't. I'm gonna use a little symbol here, perpendicular to the radius. At the point of, okay, whatever that noise is, it's making Bella crazy. At point of tangency. So what they're saying there is that if I were to put in my center for my circle, which I should have had anyway. Okay, so there's the center to my circle. And I were to make a line here from this point of tangency to the circle, I have now created a right angle. Okay, so this, from this, between the tangent line and the radius, at this point of tangency is a 90-degree angle. Okay, so that's what that's saying. So if two lines that are not parallel intersect a circle, the angles formed at the intersection of the lines are related to the arcs the lines intercept on the circle. So let's see here how I want to say this. Let me draw a new picture. So here I have a circle, right? So I'm going to say that two lines intersect my circle. There's one line, and then I'm going to make another one. Okay, so now I have two different lines that intersect my circle, right? And they're not parallel. The angles formed at the intersection. Okay, so what I'm talking about is this angle. Let me get my little pointer. The angles formed at the intersection. So this angle right here are related to the arcs right? So this angle is related to this arc that's also intersected by the lines. That's what they're saying. And then this angle right here has a relationship to the arc. So that's what that's saying. So we remember that if the vertex is on the circle, right, which is what I did here, the vertex is on the circle, this is an inscribed angle. Okay, so we're backtracking here. I'm just refreshing your memory. This is an inscribed angle because the vertex is on the circle. So this angle measurement is half of the arc. All right, so remember that the vertex is on the circle. And the angle, the measure of the angle is half the measure of the arc. Okay. Let's remember that. Okay, so now let me go to another picture. New information. So now I'm going to give you some new information. I'm going to give you this circle here. And then I'm going to draw in this illustration right here. So if two lines intersect inside a circle, right? So now my intersection is inside the circle. The measure of the angles formed equal 1/2 the sum of the measures of the intercepted arcs. Okay, so let me pause. Let me say that this is x degrees. This is 80. So do you see how the lines intersect inside the circle, right? So what I can say is that the measure of these angles, and how can I label them both x? Well, here's the x, right? So I know that these angles are the same because they're vertical angles, right? So these angles are the same because they're vertical angles. So what they're saying is that the measure of these angles is half of the sum of the two intercepted arcs, right? Do you see how this here is an intercepted arc and this here is an intercepted arc, right? Because there's my lines, right? So if I were to continue this line, I would have these two endpoints here, right? I'd have this endpoint and this endpoint, so then I have this arc, and then I have this endpoint and this endpoint here, and I have that arc. So those are my two intercepted arcs. And I know that these angles are the same because they're vertical angles, so I would take half of the sum, which 1/2 of 120 gives me 60 degrees. Okay, so this is if the lines intersect inside. So if lines intersect inside, that's the key word. So if my lines intersect inside, I add up my intercepted arcs and divide by 2. So we'll say arc 1 plus arc 2, and then divide it by 2. Okay. So what happens if my lines intersect outside? My goodness. If my lines intersect outside my circle, so let's draw a picture of that. on a straight line. So now my lines intersect out here, right? You see my intersection point. Let me get my spotlight. My intersection point is out here. It's outside of my circle. So then what I could do is I have this intercepted arc here. And I have this intercepted arc here. So if this is 40 and this is 80, the measure of this angle, the measure of the angle is going to be the difference of the two arcs divided by 2. Okay, so if the lines intersect outside the circle, the measure of the angle formed, right? The measure of the angle formed, that's this right here, is 1/2 of the difference. Okay, so if I'm outside, then I'm going to subtract. So I'm going to have arc 1 minus arc 2 divided by 2. Okay. So in the diagram here that I have here, I have 2 secant lines, right? I have 2 secant lines because this line touches at 2 points and this line here touches the circle at 2 points. So the same rule applies if one or both of the lines are tangent. So let me draw a circle showing you what I mean. So there's my circle. All right, but what if I have tangent lines? And remember, tangent just means it touches at 1 point, and we're going to say that that only touches at 1 point. All right, and we're going to say that this only touches at 1 point. So here I have tangent lines because they only touch the circle at this point here and this point here. So whether it's secant or tangent lines, my intersection is still outside. Okay, so let's write that down. All that matters is whether the lines intersect inside or outside of circle. The type of lines don't matter. Okay, it's just whether or not the intersection point happens inside or outside the circle. If it's inside, remember you're adding up the 2 arcs and dividing by 2. And if it's outside, you're subtracting the 2 arcs and dividing by 2. Okay, so let me see if I can find some example problems for you. Okay, so my intersection is outside, so that means I'm going to subtract my 2 arcs and divide by 2, which gives me 20 divided by 2, which I know that my angle measurement is 10, so x equals 10 degrees. Now what if, let's just say, what if we had something like this? So now I have this intersection point inside my circles. So I'm going to have to add up my arcs and divide by 2, but I know my angles and I'm trying to find an arc, right? So now if I know my angle, and I'm trying to find the arc, well, I can still say that arc 1 plus arc 2 divided by 2 equals the angle measurement now, right? So what I'm going to do to solve this equation is multiply both sides by 2. Okay, so then this is going to cancel, and I'll have x plus 60 equals 140. Subtract 60 from both sides. Then I'm going to have to find out that x equals 80 degrees. So I can still use this whether I'm finding angles or arcs. Okay. You have some worksheets on this. Remember, all we're looking at is to see if there is the intersection inside or outside. So you're going to be dealing with secants and tangents only. And you let me know if you need me.